So in your June exams, your prelims and your finals, you are definitely going to be asked to work out the equation of a tangent to a circle. Firstly, if you're ever going to be asked to work out the equation of a tangent to a circle, we always want to keep in mind, firstly, that a tangent is just a straight line, right? So if we're going to work out the equation of this tangent to this circle, we just want to keep in mind that it's just a straight line, and we need to find the gradient of that straight line, and we also need to find the y-intercept. With a picture like this, or rather with all questions that ask us to work out the equation of a tangent, there are two key things you want to remember, right? And depending on the information given, you will always have enough for you to work out whatever it is that they're asking, right? So if we're going to work out the equation of this tangent, the first thing you want to do is you want to get the gradient of your tangent. If we're going to get the gradient of our tangent here, we don't have 2 points that are both on the straight line, so our normal gradient formula is not going to help us. What will help us though is keeping in mind firstly that this is a circle, and anytime we're given the center of a circle and a point where a tangent meets the circle, we will always have this law, right? Firstly, this is the radius of our circle, this is the tangent to our circle. So our radius will always meet a tangent at an angle of 90 degrees. That's one of your Euclidean laws. So if we're going to work out the radius, or rather the gradient of this tangent, we are going to work out the gradient of our radius first, and then use this formula to help us work out the gradient of our tangent. Okay, so getting the gradient of our radius, let me label it mr. We know that we can use the normal gradient formula, right? So that's the gradient of our radius. The gradient of our tangent so this is clearly telling us that the gradient of our tangent, it's just going to be a -1, right? And yeah, makes sense because this is going down, this is going up. That's negative, that's +1, so this is going to be -1. So now that we have the gradient of our tangent, let's put that into the equation that we currently have, right? Because our standard form is currently empty, so we're just going to go ahead and throw in the gradient that we already have there. So our equation of our tangent is not complete, right? We still need to find our y-intercept. If we look at our tangent, we can clearly see that our y-intercept is going to be somewhere over there. And luckily, anytime we need to work out a y-intercept, we know that we usually just say, let's make x equal to 0 and then find the y-intercept. We can do that. However, in the process of working out the y-intercept, you cannot use that law, you get, because you will just end up with something like this, which is a true statement, but you have not worked out C, right? So to get our y-intercept, luckily we have a coordinate that the tangent passes through, or rather a coordinate that our straight line passes through. So if we sub in our coordinates into our current equation, this is what we have. Our y-intercept is -1. This is telling us that our equation of our tangent is just -x minus 1. Questions like this will normally be 4 marks, 5 marks, if you're lucky, maybe more, but generally speaking, this is something you want to always be able to do, especially for your prelims, your finals, and your June exams that are still coming unless you graduate them, and also like tests that you write during the term.